Thank you guys for joining this evening. We are Gravity 9, so we're a software development company. We build kind of enterprise products for generally blue chip size companies. Most of our clients are out of the US. We've got delivery in the UK and Poland and some in South America. So we're kind of a widely distributed team. We have three pillars to our product set. Software engineering is our core. We've got product, user experience and design, and then more recently AI capability to include intelligence into the products that we build. I'm going to hand you over to Loghman, who is our AI lead. One thing I actually just wanted to ask you if you turn your phones off for guys online. I'm going to hand you over to Loghman, who is our AI lead. He's going to talk you through the first of 4 sessions over the next four weeks. So
Cheers.
Place you go.
Thank you, Noel. So I'm Loghman. If I want to give you a background about myself, I'm coming from software background. I have around almost 2 decades experience in the software, machine learning, data science, and AI industry, and working in different verticals. And somehow in this series, we try to just provide a very, I think, brief overview around the AI concept and looking at different parts of that. Oh, I think I forgot to turn on the mic on the team. Sorry for the people who they joined online. So, in fact, today I'm going to just explore the different aspects of the AI and find out what is meant, how we can use, what kind of technology and field and area is exist in this area. At the beginning, we will look at the basic concepts such as AI, machine learning, deep learning. Then we will try to look at the process of learning and what does mean of machine learning, how machine can learn. And then we will look at 2 main area of AI, which is a natural language processing and computer vision. So, I think a main concept, AI is a field of study when we try to build and create systems that can think and act as a human. So, in fact, we try to replicate ourselves. But we have 2 types of AI. Artificial narrow intelligence and artificial general intelligence. At the moment, we have lots of systems which they are located in the narrow intelligence. We have very sophisticated systems that they are good at doing just one or maybe small amount of task. They are not good at generalizing as a human. They cannot hear, they cannot see and comprehend as we do. If you try to go back and look at the history, the first attempt was symbolic AI, in fact, in the AI area, when we try to create a large set of rules and the programmers try to embed those rules inside a code or a program, and then we pass the rules and the data, and the system or the program try to answer our questions. So those trends was a common trend for almost 4 decades until beginning of 1980. And then the machine learning emerged. In fact, in the machine learning concept, we try to create systems that can learn by themselves. We don't need to program them explicitly. So in fact, we swap the input and output. Instead of rules as an input, we pass the answers with the data, and the machine try to learn and extract the patterns and tell us what kind of rules exist on those data. And as a subset of machine learning, we have the deep learning. Deep learning is a subset of machine learning when we try to use artificial neural network. So I forgot to say, please stop me and ask any questions during the presentation, so feel free to interrupt me. This is the main three concepts in the AI. I think is maybe for some of you is obvious, but I try to just recap and remind ourselves. So deep learning area or deep learning concept is coming from the same concept because we try to mimic the brain of human. In fact, to create the systems that can mimic and act or work as a human brain, we need to look at the structural or the basic structure of the brain, which is the neuron. And in a human brain, we have multiple neurons. As an input, each neuron can receive data or information from the other neurons through the dendrites. And then we have the soma, which is try to do some analysis and generate the signals to create some outputs and pass the information to the rest of the neurons. So to reproduce the same concept, we have mathematics. In fact, with mathematics concept, we can regenerate the same concept. We have the input x1 to xn, then we have some weights, and we can calculate some simple mathematics equation and generate output. So this is exactly the same concept as a one neuron. And if we try to put a group of neurons together in different layers, we will create a neural network. So in fact, a neural network is a group of layers or group of neurons in different layers. The first layer is input layer. When we pass the input data, we have some hidden layer, and finally at the last layer we try to generate the output, and we store the information or knowledge on the, those connections between the neurons or layers. So all the knowledge will be stored as a numbers inside those connections. So this is just basic concept of neural network and deep learning. And when we say deep, it refers to the multiple layer. For example, this network is a very shallow network because it has just two hidden layers. But if we try to increase the number of the hidden layer in the middle, let's say, for example, 50, 100, then it will become a deep learning model.
Just for an example there, like the inputs would represent something like, if you're looking at an image, it might be a pixel or something like that. So those input layers are quite large, like presumably thousands.
That's true. So in fact, as an input, we can pass numbers, all the system, because we have the mathematical equation, the input always will be number. And we need to convert the input or the data from different shapes, format to the numbers before feeding to the neural network. So how machine can learn? This is the main questions. If you try to look at the traditional way of learning, so in fact, we need data. The basic of the AI or all those concepts is data. And for example, if you try to predict the heart attack, at the beginning, we need to collect some data. For example, in this case, we have age, weight, smoker status, and finally, we want to predict the heart attack. Then we need to label the data. So we have some features or input data. For example, the first 3 columns will be the data as an input, and we want to predict the heart attack. So this one is the target and or label. Then we have the training process. So in fact, we try to divide our data in 2 or 3 sections. In this case, I try to simplify the concept. We have the training set and testing set. So the data will be used for training. So this is the training data set. We feed or send this data to a model or to an algorithm. So this algorithm, we have 100 or 1,000 of algorithm, and we need to select one of them, then send the training data to the algorithm, train this algorithm based on that training data to predict the correct value for the labels. And then we will try to evaluate this model using the testing data. When we satisfy, we will repeat this process multiple times. And when we satisfy with the result of the prediction for this algorithm, we will put the model inside the software to use and provide access to the end users. And then the inference phase started when we have a new data and we want to predict the labels for those data. For example, in this case, somebody with age 75 and 98 kilo weight, and he's smoker, so the model can predict is that person goes to have a heart attack or not. So as an example, I think it's nice to see a sample. You don't need to understand the code. It's just very simple example. We try to predict the ride fare for Uber, for example. Just we want to simulate the concept. We have some data. The input will be the distance that the person wants to travel, and the output will be the
sharing that.
Oh, it's not sharing. I need to stop the sharing, I think. I need to move that one to the other screen. In fact,
there you go.
So in this case, I need to move to this side. So in this case, what we have, in fact, I'm trying to find the mouse. It will be a little bit difficult to...
Oh, you got it. It's over there.
Yeah. Oh, yeah. So as input data, we have the distance, and as an output, we want to predict the fare or the cost for this travel. So we created a small data set. Then what we did, we need to check the data. So the first part is just to see and visualize the data. It's very simple. The distance compared to the ride fare, and as you can see, the data is distributed on that plot. And we can see it's very easy to use a line to somehow predict the value for those. So if I try to go down, so in fact, at the beginning, we created the features and the target. We separated those two items and just trying to repeat the same concept of the training. Then we have the training data set with the test data set. Then we converted some of the numbers and the input value. For example, we have the to be in the same range. We try to use a linear model, which is one of the machine learning model. It's a linear regression, and then we train the model. So I will skip this rest. In fact, this red line is the model that we created and we trained, and those blue dot is the test value or the test data, and we can see and evaluate the our model. The average difference between the prediction using this line with the actual fair value is almost around $1.70. So it means the model can predict very well. So then what we can do, in fact, we can use the trained model to predict next, I think, requests for the new client. So for example, if somebody wants to travel 3.5 miles, so the price will be that, and so on. And what we can do, we can save this model, put this model inside the software and use the model repeatedly. So yeah, this is just one example. just to show you. In this case, in fact, let's keep it here because I think I need to show the other one as well right here. So, in fact, we have the label in the first option, but sometimes you don't have any labels to predict and the data is not prepared. Hopefully I can find having to screen it get tricky. So sometimes we don't have any label or target variables, and we call those kind of problem unsupervised problem. And we are looking to find pattern inside those data without knowing anything from the beginning. So in this case, for example, we want to cluster our customer data into different segments and put them in different segments specifically for marketing purpose. So if you have a list of the customer, how you want to target them for different campaigns. So in this case, what we did, in fact, this is the data set that we have. In the data set, we have the customer ID, gender, age, annual income, spending score. So the spending score is a number between 0 and 100. So in fact, it shows how much this person spent in the past. And then we can check different aspects of these data set or our client specification. For example, at the beginning, we can look at the age range, how the client distributed based on the age. For example, in this case, we can see almost around 35% of our clients have the age between 30 to 40 years old. Or if you try to visualize, we can see or compare the annual income, and I think the vast proportion of our client income is between 50K to almost 80K, and so on. So we can look at the spending score. So we have lots of clients with spending score between 40 to 60. And if you try to plot the data at the beginning, it's so difficult to understand what kind of groups we can think about them. So for example, in this case, we have the age, annual income, and the gender. So the gender, the blue one is male, orange one female. So it's so difficult to find the people to target for a specific marketing campaign. But we have some sort of algorithm. I will pass that one because it gets some technical, but after running and training a model, it helps us to extract meaningful concept or information. For example, in this case, we reach to the point that we can say we have almost 5 different group of customers. For example, the red customer, the customer who they located in this area, their income is more than 65K. And if you look at that, the spending score is less than 40. So now that we know this group, they have a higher income, but they spend less, we can target them and somehow maybe we can convert them to the other group, to the group that they spend more on our products. So this is just some samples of different application of AI. Do we have any question? I think it's good to have a pause. Give you time to breathe and digest the concept.
I guess just in summary there, we're talking about supervised, unsupervised. Supervised, you kind of know the answers and you try and map the category of the data, and then unsupervised is telling you more about the data than you already know. So it comes out of the data, doesn't it? More of a characteristic. And the data, and it seems, if you look through the training of a model, the data's probably become more important. Do you think that's one of the reasons why I mean, I guess AI is taken off, but like we've got more capacity for storage and process now. So the data is as important as the algorithm, I guess. It's probably the important thing.
That's true. That's true. So, in fact, data is look like a fuel for the AI systems. Without data, we cannot do anything. And I think next session I will try to speak more about the data, the importance of data, how it can impact different organizations, how they can harness the power of the data and the hidden knowledge that is stored inside the data. Mm-hmm. So let's go back to the presentation, and hopefully I can find my mouse. Oh,
we'll see that. Our heads are not in the way of that.
This gets so difficult. Or it's better maybe to close just directly. Okay. And so now that we have an idea how machine can learn, let's look at different type of learning. I think we saw two of them. In fact, supervised learning and unsupervised. Supervised learning, we have a different type of learning. Machine can learn with different approach. I just mentioned three of them here, but there are more, and you can find more of those kind of techniques. Supervised learning, when we have the output alongside the data, and we try to predict these labels, we call them supervised. But when we don't have any label for prediction and we need to find a pattern, so those group of problems sit inside the unsupervised learning. We have another kind of learning concept, and one of the important one is reinforcement learning. In the reinforcement learning, we try to create agent or somehow objects that try to act inside an environment, and we try to give them rewards or punish them, and they will learn based on this process. Reinforcement learning is very similar to training a dog, in fact. When you try to train a dog, you try to give treats, and they will learn, is it okay to do that or not? So the same concept is existing in the AI. And then in the supervised, if you go back, if you have the label, we have two types of supervised learning, classification and regression. Classification is a group of problems when the output or the label is a district number. So the output, for example, when we try to predict an object or classify image to different classes, for example, 10 classes or 1,000 classes. So this kind of algorithm, we know the number of classes. We call them categorical. So in fact, the output is a category, or they are a group or category title. For example, customer retention. We can say or predict is customer return or not, or fraud detection, is a transaction is a fraud or not, or we can detect spam email, is this email is spam or important email, or is it for example, promotion email, so we can group them, categorize them. Spotting cancer cell, for example, if you have an image of medical cells, so somehow we can classify them, is there any cancer cell inside or not? Or image classification, put the image in a different group. The other group is a regression. When the output of a model is a number, so we have the regression problem. For example, predicting house price based on the house house specification, number of bedrooms, areas, transportation links, and different factors that can impact on the price. So the output is number. Stock market prediction or sales and demand forecasting for a specific product. Weather forecasting also. Those group of problem, the output is a number. Because of that, we call them regression. For unsupervised learning, we have clustering and association or mining. So again, some just concept. Clustering, when we try to put the data in different groups. For example, customer segmentation as a sample that we saw, or image segmentation when we try to assign each pixel inside the image to different segments. Why? To find the different object inside the image. Or anomaly detection, when we have a group of data and we want to spot anomaly inside those. Social network analysis, recommendation system, for example, on the website, or better say on the Netflix, Amazon, every day, when we try to do some sort of purchase, they try to offer other products. So they are all clustering. Association rule mining is another group of unsupervised learning. When we want to find a relation between different data points or feature inside the data. For example, I think today, any retails, I think we cannot find any retails that they are not using this technique. Market basket analysis, specifically when we try to go to the, for example, supermarket, and when we check out, they have the data what we bought, and then we collect all those information. Then they ask them, okay, let's find a relation between different items in the basket. If somebody, for example, try to buy egg, are they going to buy, for example, milk at the same time or not? So, okay, now we have an idea how we can arrange different items in the store. Or diseases diagnosis, finding a relation between symptoms with the disease. Or search engine optimization. This is another application of association rule mining. And for reinforcement learning, I think for some of you it might be too much, but I just list some samples. In the reinforcement learning, when we try to train a system by rewarding or punishment, so we have different samples, such as playing a game, so we can have a application or software that can learn from the error. Or robotic arm control, when you have a robot and it try to learn from its mistakes. Autonomous vehicle, I think, is a very general concept at the moment. Specifically, auto park, for example, lots of car at the moment, you can use a key and it will park by itself. So it learns from the mistake at the beginning and it fixes itself every time and learn to avoid any obstacle. Medicine discovery is one of the very important one, and specifically, for example, during the COVID, Moderna is another, I think, a very obvious example. They didn't follow any traditional procedure for vaccine discovery. In fact, they used the AI. Energy management, algorithmic trading in finance. Lots of markets now, they are using the AI to do the trading. So this is some summary of, I think, lots of different concepts in AI. Do we have any question?
Here we go.
Yeah. Any comment? No? Great. One of the main, I think, advancements in the specifically past 2 years is in the area of natural language processing. So natural language processing is a very important part of the AI. Let's see what is this and how it can help us in our life. So in fact, NLP, or natural language processing, is a part of the AI when we try to analyze and understand human language. So in fact, in different form and shapes, to say, for example, spoken, written, or in fact, in different languages, system try to understand our language. So the NLP is a group or an area of science that we can, at the beginning, create a system that can understand our language and then generate data that is similar to our language. So in fact, NLP has three sub area or subfields: natural language understanding, natural language generation, and speech recognition. So let's look at each of them. I think it's better to have a deep dive a little inside the concept. Before doing anything for a system, it needs to understand our language. So how we can create a system that can understand? We have NLU, natural language understanding. In fact, computers cannot calculate or process anything rather than numbers. So to create a system that can understand our language, we need to convert the language to the number. So we call this process embedding. In fact, we have some sort of AI models that they take the text as an input, for example, in this case, and they create numbers. And those numbers, they contain the meaning of the language. It's not just a number, because the context is important. When we are speaking, we try to convey a context. So in fact, the embedding, we call them embedding. Those embedding is a group of numbers that try to reflect the meaning of the text. And we have a different application for natural language understanding. For example, search engine. When we try to write something, a query on the Google, before receiving any or providing any response, the Google needs to understand the meaning of the query and then run the search. Or classifying important emails. So the content of the email should be understood by the system and then find the importance of this email and categorize that as an important email. Or reading comprehension, when we have, for example, a large amount of text, and if you want to, for example, summarize this text. So, or medical diagnosis based on symptom description. So there are lots of applications for natural language understanding. So if I go back, in fact, generally, without AI system, from the beginning of the computers, we try to, for example, convert the letters to the numbers. For example, in this case, we have the ASCII code. ASCII code, in fact, for each letter, we assign a number. And then we put them together and save those numbers inside the computer system to store the information, and then we can retrieve those and convert them. And if you look at that, in fact, the difference between listen and silent is the order. So we have similar character, but the order is different. But the system can understand this difference. So this is the storing text inside the computer system. We have the same concept for embedding. So for example, if you have a sentence such as I love my dog, and then I love my cat. So what we can do, the simplest way to, for example, create an embedding system or a system that can convert text to the number, we can assign a numbers. For example, 001 for I, 002 for low, and so on. And then if you put those numbers together, we have a vector. This is the vector for the first sentence, and this is the vector for the second sentence. And now we have a mathematical representation of those sentences. We can compare them together. And because both sentences, they are talking about, for example, pets, so they are similar. And if you run, for example, very simple mathematic minus operation or subtraction, so in fact, those two vectors, they are very close to each other. So this is a natural language understanding. If you want to, this example that I showed is very simple. It doesn't have any meaning in the numbers. But with the embedding, in fact, we try to put the meaning inside the numbers. For example, this is a more advanced version. If you try, for example, embed some words such as a cat, kitten, dog, house, man, woman, king, queen. So we can think about different categories. For example, living being, feline, human, gender, royalty, verb, plural. And then assign some numbers that is represent the relation of these word with this category. For example, cat, living being, 0.6, or feline, 0.9. But if you come down, for example, for dog, the relation with the feline is minus 0.1, and so on. Now, in fact, we try to embed the meaning inside the number. And if we simplify the representation and plot them on a 2D diagram, we can see words with the similar meaning will sit close to each other, while the words that they have a different meaning, they will sit apart from each other. So also we can check, for example, or compare those items together. For example, the difference between man and a woman is equal king to queen. So in fact, it provides mathematical options to do some sort of similarity check. Let me show you just an example here. I think that one would be interesting. This is a example from the Google. So in fact, in this website, you can check the embedding. This is a representation of, we have a different kind of embedding system. This one called word vector, and it try to create embedding or number representations for 10,000 words. And if we try, for example, to select one of these words, if I can find it's here. For example, to select one of these. Hopefully I will be okay. For example, when we try to, to select the bin, when we choose these words, you can see similar words, the words that they are close to these words. In fact, because they have similar meaning. So somehow word embedding is a tool to understand the meaning of.
And that represents meaning and relationship. So,
exactly.
So bean isn't related to liver, but there's a relationship between those two things in the context of that model.
That's true. That's true, yeah. I prepared that code, but I will skip that one because if you like, I can share later on how to create, for example, embedding for your data. Sometimes, for example, let's say if you have a data for a specific domain, the embedding should be different from the other domain. For example, the language that we try to use in, for example, law and regulation is so different compared to the, for example, language that we try to use, for example, in a transportation, or maybe in a, I don't know, other domains, healthcare, or those kind of things. Do we have any questions? Hopefully, yeah.
I have lots, but they're coming and going. When is this just written language? Because I've sometimes had a book that has spoken to me and it's a computer speaking it. Is that how this is working? It will read the text and then turn it into sound?
Exactly.
And can it go the other way? So is that how Alexa understands my voice?
Exactly. This is I think the next part of the presentation when we try to,
Got another question that relates to that cluster that you had, that embedding. Could AI then be teaching people English? Could you use AI to teach English to speakers of foreign languages?
100%, yeah. So at the moment, for example, as I mentioned, ChatGPT is one of those models that lots of people try to use to learn English or create applications that help foreign people to learn how to speak, or maybe improve their writing, their understanding, and somehow is integrated with our life now. Yeah.
And then you organise that with the groupings of words for the computer to understand. Is that similar to how the human brain organises words? Is that where you've kind of got it from, or is it just what seems to work for AI?
So, in fact, we will store those numbers. And then if you have, for example, different input data, let's say, for example, it could be files that contain text, or it could be files that contain some sort of, for example, audio or visual elements. So then what we can do, in fact, we convert those data to the same representation as we have. So it looks like a dictionary, this embedding, and we try to find the same concept, create the same item, and then use those embedding to do different tasks. For example, in the next slide, I will explain the natural language generation, where we try to use the same embedding or numerical representation to generate text or generate speech. Yeah, it depends on the hand in task. Yeah, task in hand and what we want to do.
Yeah, I think it's a fair statement to say it is replicating of the human brain, certainly neural networks, but also pattern matching generally. That's that's how we do it, and I think lots of AI is taken from like the real world, and certainly how the brain works and how we memorize and classify and see things. I think it is heavily influenced by how we do it, just in numbers.
Exactly. In fact, we want to replicate ourselves. This is the ultimate aim, but we are far from that. So the next part of
And so when something like ChatGPT comes out with a new improved version, would you predict a large element of the improvement is coming from a better embedding algorithm, or would you say it's a mix of those other things?
It depends. I think it depends. For example, now Google introduced Gemini, I think almost at the end of December, and they try to improve the understanding by integrating different elements. For example, it could do multiple tasks. For example, more tasks compared to the ChatGPT. And it tried to, for example, improve in some of the tasks that ChatGPT can do the same things. But it's all about I think, about the application, what we want to do. And the embedding exactly is during the, I think, history of natural language processing, by improving and increasing the size of the embedding. So in fact, we can factor more information and embed more information inside these vectors. So if you have a larger or a bigger size of embedding, definitely we can create more powerful systems. But there is limitation always, because systems cannot, and there is lots of calculation needs to be done to, for example, generate the embedding, at the same time reverse the process for natural language generation. So the second sections or the second subfield of natural language processing is natural language generation. When we have the embedding and we want to create a system that can generate the text, for example, in this case, and we call them NLG. And I think there are lots of use cases such as a spelling and grammar correction or chatbot or machine translation, translating text from one language to another, or recently writing programming code. So in fact, we have model that can write the code instead of the human. We have different architecture to do that, or neural network architecture. I just mentioned some of them. You don't need to know about them, but recurrent neural network or long short-term memory or transformers, there are some sort of main architecture for algorithm that we try to use for natural language generation. So if I try to simplify the process of generation, it's almost about the predicting next word, specifically in the text generation. When we have a text, we want to create a model that can predict the next word in the sentence. So maybe the most intuitive sample is Fibonacci numbers. So in the Fibonacci number, we try to, for example, start with 1 and 2 and create a series of number, and always the next number is equal to the two previous number together. So in fact, we will sum 1 with 2 and we will receive 3. And then we will bring the 2 and we will sum the 3 with 2. It will generate the 5. Then we will pass the 3 and sum them together to predict the next number in this series. So we have the same concept in the natural language generation. In fact, if you have a sentence such as that, for example, today the weather is nice and I see a beautiful blue. What is the next word? Now system need to predict that one. So we will pass first words. We will expect the model to predict the next word. And then so on. So each time the model will receive one word and it will try to predict the next word until we will generate the correct answer or prediction for the next word in this sentence. So this is the process of language generation, and it's all based on the probabilistic or probability. So they are not static model. Every time you try to ask an AI model, they can generate different output for you based on the probability of, I think, concept, the probability of the output. Do we have any question? And the last part of the natural language processing is speech recognition, when we have text to speech and speech to text. So in fact, we can convert text to speech, and at the same time, we can generate text from the speech. And they have lots of application. For example, for text to speech, one of the nice applications that I saw is synthesizing Hollywood actors' voice. So instead of inviting them into the studio, spending multiple time going through the script, recording that, so there are some AI models that can generate the speech. They pass the script to the model. They configure the model, for example, the tone, the volume, I think the different characteristic of the voice, and then the model will generate the speech for them. Or I think recently I saw very nice application, music generation. So you can write a text. I think musicify. I think, I'm not sure, but If you search, you can write a text and it will generate the music based on your description. For speech-to-text, movie subtitle, call analysis, one of the main applications of speech-to-text in customer support teams. And today it has lots of applications, specifically to, for example, run some sort of sentiment analysis on the calls, understanding the issues, and finding more information. And media content search, for example, when you try to search the YouTube, in fact, it try to use the speech-to-text somehow to generate the textual information about each media, each video. Great, we have different tasks that we can use NLP to do for us. Those are more technical concepts, look like in language modeling when we try to create a model of a language, text classification, information retrieval, information extraction, conversational agent, text summarization, question answering, and we have multiple different tasks at the same time. They can be used for different applications such as a search engine, sentiment analysis of customer review, or screening, for example, CV or resume during the hiring process. So lots of, I think hiring system at the moment, they are using AI system to scrape the information from the CVs, classifying document to different groups, and so on. I will skip that. If there are any questions, do we have any questions or?
Just, I mean, I suppose just not a question, more of a maybe a response to the question around the increasing the power of, say, ChatGPT. That's about the size of the data, the number of processes, the algorithms, and the closeness. It's a combination of things, isn't it? That brings, version 5 out will be more powerful.
Exactly.
It's about the data and the data points, isn't it? That would sort of make the next version more powerful.
Yeah, the data is really important, the amount of data that they try to use for training those kind of model, and then the structure of the model or the architecture is another concept. For example, we have smaller models that they outperform the larger model because they optimize the architecture of those models and they try to enhance the process. And I think lots of factors can impact on the process and provide a better models. So I will be quick for the last part, which is another area, very different, computer vision. Vision is one of our, I think, main sense. From the childhood, we learn a lot by see our environment, our surrounding. And the same things is true about the computers. So computer vision is the area when we try to create systems that can understand the world as we do. There are lots of applications from face recognition. I think everybody now has a smartphone that they can unlock the phone with their face, or using the computer vision to detect for example, tumor in the brain. And specifically in the healthcare, computer vision has lots of, I think, improvement. And today, hopefully we will see more, but today we try, I think the whole industry try to enhance the process specifically to mitigate the human, I think, error through the process. Self-driving cars is another application, which is very obvious, but is not based on the only computer vision. In some cases, for example, Tesla is fully based on the computer vision, but we have some sort of systems that they try to use the other input data, such as a LiDAR or radar or other kind of input data. In the retail, for example, Amazon Fresh Store, now you don't need to stay to pay in the cashier. You will pick your product, put the product in the basket, go out, and they track everything using the computer vision systems.
Yeah.
In the agriculture, crop monitoring and analysis is a very common, I think, specifically with the demand in this area. Manufacturing, lots of, I think, factory try to use the vision system to for quality control in the process of the manufacturing. Security and surveillance, so I think is another area, specifically when you try to run events. Our event is small, but for large events, it's important to look at the different aspects of the security. Sport analysis, lots of money goes to these at the moment, specifically in the, I think, for the football fans. We can see lots of application. For example, one of the projects that I work is predicting the location of the ball in the next 2 seconds, just to help the coach to somehow arrange the team in a better positions. Fashion, virtual try-on, I think, is a normal application for computer vision. We have different capability. The first one, image classification. When we have an image, then we say this image, for example, is a cat, dog, or some things. Object detection, when we try to detect different object in an image and we try to specify the location of those image or object in the image. Segmentation, as I mentioned, for example, when we try to allocate or assign each pixel inside an image to different segment, specifically for self-driving is one of the main applications today we try to use. Motion analysis, so it helps, specifically in the healthcare, we have lots of application for rehabilitation, or in the sport, for example, they try to use the computer vision and motion analysis to help the athletes. Image restoration, so in fact, bringing quality to the old life. Edge detection, this I didn't put anything, but it's a basic concept in the computer vision when we try to detect the edge. Specifically, again, it has a lot of application, but in the autonomous car, self-driving. For depth perception, when we want to calculate the distance, depth based on the moving object in a video or, I think, photos. Image super resolution, so it has lots of application. One of them, for example, just to improve the quality of the image if you have a very old image. But the main, I think, one of the main application for satellite image, because lots of them, they don't have enough quality, and we use those to improve the quality. Object tracking in the video, so when you try to, for example, track different objects, is one of the applications that I developed, just to track different objects from the car, from the human, and counting them or maybe tracking them based on the different application. Optical character recognition, or OCR, when we want to digitalize the old data on the papers. For example, in this case, we want to extract all the information from an invoice and digitalize that one. How computer can learn, or computer vision can learn. So I will be quick. It's a very simple concept. For example, if you have some people, and a group of people look like Amy, Luke, Danny, Mike, Rachel, Peter, and if you try to train them to answer our questions, and the question is very simple: is this photo is a panda or not? So what we will do, we will assign different responsibility to each person. So for example, Amy will be responsible to identify the ears. Then Luke will be look at the eyes only. Then he will check the nose and so on. For example, Mike pose and Rachel tell. Then we will show them multiple photos of the pandas. They will learn very well about those features, and then they will pass their finding to the next person, which is Peter. And Peter is responsible for the face. So in fact, the output of the first 3 people will go to the Peter. And then they will decide, for example, how much important each element to recognize the face. They will assign some number here, and the same things will be going on the bottom side to the Julia to decide about the pose and tells, and then these 2 people send their finding to the Juditha, and Juditha is responsible to say is this photo is a panda or not. Now they learn. So in fact, the learning is those numbers that we have. If you pass a new photo, they will evaluate the different part, and they will send this information to the next people. So we will multiply those numbers together, and in fact, we can find, for example, this face is far from the panda face, or this part as well. And based on that, the model will say is not a panda, is a bear. So this is the whole process for a neural network or artificial neural network. Each node somehow responsible to detect some things in the computer vision. I try to be very quick, but this is the presentation. And as a takeaway, I'm just trying to recap what is artificial intelligence when we try to create machines that can think and act as a human. Machine learning, then machine try to learn by itself without human involvement. Key step for training a machine is data collection, labeling the data, training an algorithm, iterate the process, evaluate the output, and then inference using a new data. Deep learning is a part of the machine learning when we try to use the artificial neural network. NLP is a part of AI that we try to analyze data similar to the spoken or written data. Natural language understanding when we try to understand the natural language. And word embedding is the numerical representation that try to store the meaning of the natural language. And NLG is a part of the NLP that try to generate the natural language output. Speech recognition, try to convert text to speech or speech to text. Computer vision, when we try to create system that can analyze and understand the visual element. Thank you very much. So I highly encourage you to follow us on the LinkedIn. If you like, you can scan the barcode and it will direct you to the a LinkedIn page. And thanks a lot for listening.